And welcome to Technology Tap. I'm Professor J-Rod. In this episode, we're going to talk about Linux Part 2. Let's tap in. All right, welcome to Technology Tap, Professor J-Rod. For those of you who don't know me, I'm a professor of cybersecurity, and I like helping my students pass their A+, Network Plus, and Security Plus series of exams. I'm also wrote the book Scam Proof for Life, right, to help seniors. Scam Proof for Seniors. I say Scam Proof for Life. No, Scam Proof for Seniors. To help, your mom, dad, grandma, grandpa, uncle, aunt, help them not get scammed. Because, there's a lot of scammers out there. You can find that on Amazon. It's called Scam Proof for Seniors, written by me, Dr. Rodriguez. Or you can find it at my website, Professor J-Rod, that's JROD.com/books, and you will see it there. And you can order it at ProfessorJRod.com. Yeah, it's a good book. Buy it. Support the show, support me, and help out your parents, grandparents, all that. Makes a great Mother's Day gift, by the way. Mother's Day is a few weeks away, so, if you don't know what you want to buy your mom or grandma for Mother's Day, this is a perfect Mother's Day gift that you can buy. Again, it's on Amazon if you want. Scam Proof for Seniors. Or you can, buy Dr. Rodriguez. Scam Proof for Seniors, How to Recognize, Avoid, and Stop Modern Scams. You can buy it on Amazon or on ProfessorJRod.com/books. All right. So this is part 2. I'm also on social media, as you know. I'm on TikTok at Professor J-Rod, Instagram at Professor J-Rod, and the Facebook Technology Tap Podcast. So, all right. So let's move forward, picking up from last episode, right, where we talked about where I am in as far as Linux is concerned and who is allowed to act. Right now we reach the next question: what is the system actually doing right now? You need to understand who has permission for what, right? But permissions alone don't tell you what's happening. A system have correct permissions, can have a valid users, and have proper structure, and still fail. Why? Because something is actively running incorrectly. So the question is, what is the system doing right now, and is that behavior correct? Because operating systems are not static. They are collections of active processes. So a process is a program that is currently running in memory. Example, a web browser, a background service, a system task, a malicious program. Why does this matter? Because problems are rarely, like this file exists. They are always something is using, blocking, or breaking that file. Users see apps, windows, and icons, and you as a technician should be seeing processes interactive with system resources. So your first tool that you're going to run in Linux to see what's running is the PS command. PS command displays a snapshot of current running processes. So, for example, if you PS space AUX, what this shows? It shows the user who owns the process ID, the usage, the CPU usage, memory usage, and the command, what is running. Why is this important? Because it answers what exists at this exact moment. Next tool is the top command, TOP, displays real-time system activity. Right, what do you see when you type in top? You see live CPU usage, memory consumption, running processes, and system loads. What's the difference between PS and top? PS is a snapshot and top is live monitoring. And why does this distinction matter? Because troubleshooting depends on if the problem is consistent or dynamic. Right? In the real world, the users say my computer's slow, right? The wrong approach is to restart, guess, or blame hardware. But truth be told, restart helps a lot, right? Technician approach, you hit top, you observe that the CPU is at 100%, and you have one process consuming resources. The issue is not the system, it's a specific process behaving bad. Next, you have a PID. Right, process ID is a unique number assigned to each process. Why does it matter? Because you don't stop programs by name, you stop them by identity. Kind of like task manager, right? Or task kill. Right, this is the kill command, sends a signal to terminate a process. Right, if you've done task kill in Windows, it's similar. Right, you just do the kill and then whatever the process ID number is. Right? So, for example, if you do kill space 1, 2, 3, 4, it targets process with the ID number of 1, 2, 3, 4 and attempts to stop it safely. Now, for stop, sometimes you try to kill it and it won't do anything. It still continue running. Then you have to force stop it, and that's the -9 command. So in this example, it will be kill space -9, 1, 2, 3, 4. The -9 forces immediate termination. This is not clean. This does not save the data. It does not close gracefully. You should only use this force only when control has already been lost. Background versus foreground. Foreground runs in the active terminal. Background runs behind the scenes. So, for example, processes with the and stamp, right? The and, right? AND, right? Remember the symbol and? So, why does it matter? Because many system services run without user visibility, and it tells you what services are running. So, what's a service? A service is a background process that performs ongoing system tasks. For example, web servers, network managers, security services. Systemctl or system control. It controls system services. For example, you want to do systemctl space start Apache 2 or stop Apache 2, right? Systemctl stop Apache 2 or systemctl status Apache 2. Why this matters? Because if a service fails, that system might appear normal but function incorrectly. So let's say the website is down. You don't guess why it's down, you check. Right? So you will go systemctl space status space Apache 2 and see what's the status is. Result, the service is stopped. The fix, systemctl space start space Apache 2. Problem solved. Easy peasy. Right? Package manager. It's a system that installs, updates, and removes software. Why does it exist? Because Linux does not use random installers or download and click workflows. It uses trusted repositories. Common systems is APT, Debian based, or DNF, Yum for Red Hat based. So an example is you want to update your stuff, right? APT space update or APT install NGINX, right? For Debian based, and for DNF and Yum, you write DNF space install space HTTPD. Why this matters? Because software is verified, managed, and controlled. Now we come back to something that we're familiar, right? The ping command, right? The ping command tests connectivity between systems. It works exactly how the Windows ping command is, right? So for example, you want to ping Google, it's ping space google.com, right? What does this tell you? That the network is reachable and then the path exists. Next, we have the dig command, and dig test DNS resolution. So again, you do dig.google.com, right? What is the difference between ping and dig? Ping test for connectivity, dig test for name resolution. Next, we have the etc resolve or resov.config. Config, yeah, CONF, not config, conf, right? File that defines DNS servers used by the system. Why this matters? Because if DNS is wrong, internet works and the names fail. Automation, cron. Cron is a scheduler for automated tasks. Examples, cron tab -E. What does it do? You can use it for backups, updates of scripts. Why does it matter? Because real systems run tasks without human interaction. You don't need to be there 24/7, right? You could just set it up, especially now with AI. Set it up on what, and you don't have to be there. Now you understand that systems are not static. They are active environments. You know now that what processes are, how to monitor them, how to stop them, how the service operates, how software is installed, and how network is validated. And now we moved to the final part, right? How does the system hide complexity without removing control? Right? In Linux, everything's exposed. You type commands, you see structures, you control behavior directly. Mac OS takes a different approach. It asks, what if we kept the power but removed the friction? What Mac OS really is, most people describe Mac as easy, clean, and user-friendly. All true, but incomplete. Mac OS is a Unix-based operating system designed to combine system-level power with simplified user interface. The last part matters because Mac OS is not simpler. It is structured differently. Linux says you are responsible. Windows says we'll guide you. Mac says we'll simplify the experience, but the system still follows the rules, right? This is not a continuation of Linux, but this is just showing you the two main operating systems that, other than Windows, because the exam is like 90% Windows. The other two operating systems that could possibly be on the exam, though, do not, like, you don't need to be a Linux guru or a Mac guru. I mean, they're only going to ask you maybe 5 questions total on both exams, I would think, on Linux and Mac. It's not, it's Windows-centric, this exam. It's supposed to be vendor neutral, but it's really Windows-centric because mostly everybody has Windows, right? 90, 80, it's like 85% of the world uses Windows. So this is what the exam is based off. All right. Let's start with the Finder. Finder is the file management interface used to navigate and organize files in macOS. Why does it exist? Because not every user needs command line precision or system level visibility. Instead, they need clear visual access to their files. Right? So instead of CD users, Juan document and then type ls to see the list, you click Finder, open documents, and then view files instantly. The system didn't change, the interaction layer did. Right? The dock. The dock is a shortcut bar that provides quick access to frequently used applications. Why does it matter? Because macOS separates navigation or Finder from access, which is the dock. The results, users don't search for apps, they launch instantly. Next is Spotlight. Spotlight is a system-wide search tool that allows users to quickly locate files, applications, and system functions. The shortcut is Command plus space. That's the shortcut for that. Why this changes? Because instead of navigating folders or clicking menus, you ask the system directly. right? You could type terminal, press enter, and then system opens terminal instantly, right? That's the example. Insight search replaces navigation, and speed replaces structure. Under the surface, Mac is still Unix, and so is Linux, right? It's a father, right? Unix is the father, and Linux and Mac are the sons. Here's what most users don't realize: Mac OS is built on Unix, right? Why does that matter? Underneath, it has the same file system concept, the same permission models, and the same command line tools. If you open terminal in Mac and you type ls, pw, and cd, they're the same command as Linux. Mac OS didn't remove complexity. It hid it until you need it. Right? I bet you didn't know that ls, pw, and cd work in Mac, like in Linux. File system structure: Mac OS uses structure directories. You have your application directory with installed apps, system, which is your OS files. Library is where shared resources are, and the users is the user data. Why this matters? Because when troubleshooting, you must know where things live beneath the surface. Next, we have the security that they have available in the Mac OS, protection without constant user input. You have your file vault, full disk encryption for Mac OS, kind of like BitLocker, right? Why does it exist? To protect data if the data is lost or if it's stolen. Real world impact: without file vault, data can be extracted physically, and with it, data remains encrypted. Keychain, which is your password management, is a secure storage system for passwords and credentials. Why does this matter? Because users reuse passwords and forget credentials. This is something that Windows does not have, which I imagine in the next version of Windows they will. Because not for nothing, guys, this thing with the passwords has gotten out of hand. Changing the password every 60 days now and having 16 characters, this is like the minimum that the government wants. I mean, we still, in the corporate, it's like 90 days, I think 12 characters, but it's going to go that way pretty soon. You watch, the government is often the lead, and then the corporations follow later on. But yeah, it's a hassle, these passwords. So they reuse the passwords, they forget the credentials. So solution: the Mac OS stores and protects them securely. Backup: Time Machine. Time Machine is an automated backup system that allows users to restore previous versions of files. Why is this powerful? Because it changes how recovery works. Real world scenario: user deletes a file. Instead of panic and rebuilding it, they open Time Machine, go back in time, and restore files. Lesson: backup removes fear. I'm not a big Mac user, so I don't, I know Windows have the system restore, but the system restore does not restore the file if you deleted it. It'll restore the app, I think, if you deleted it, but if it's the file, I think it's gone. So, troubleshooting in Mac OS: even though Mac OS simplifies things, problems still exist. Force quit, right? You have the force quit command. It's command plus option plus escape. It terminates unresponsive applications, right? It's like Control Alt Delete in Windows, and then you go in there and you end task, right? To terminate unresponsive applications. Why does it matter? Because sometimes processes don't respond to normal control. Activity monitor: it displays running processes and system performance, right? Equivalent to top or task manager looks like. Identifies high CPU usage and detect misbehaving apps. Recovery mode is command plus R. Purpose: provides tools to repair or reinstall Mac OS in case of system failure, OS corruption, or disk repair. Safe mode starts Mac OS with minimal drivers and services. Windows has the same thing, right? Because it isolates software versus system issues. Why does the Mac OS feel easier? It reduces visible complexity. I don't know if it's really easier. User decision making, but still relies on structured system behavior. Remember, I'm going off the CompTIA Cert Master slides in order to do this podcast, right? So I don't think my personal opinion, and that and $2.95 gets you on the subway. I don't know how much it means, but I don't know if Mac is easier or not, right? It's visible complexity, user decision making. It relies on structure, system behavior. So now that everything is connected, you've seen Linux, full control, full responsibility. Mac OS, control, simplicity, and hidden structure. The real lesson, different systems, same principles. Files must exist, permissions must align, processes must behave, and system must be recoverable. And once you understand that, you stop memorizing systems, you start understanding systems. And as you can see, they all follow the same basic rules, right? Files in place, security, right? What to do if the process misbehave, how to recover. They all do it. So now you have structure, control, behavior, and interface. So let's test your thinking. And it's time for the CompTIA style questions. As you know, I give you 4 questions. I'm going to read it, give you the 4 choices, then read it again, give you 5 seconds. Think about it, and then I'll tell you the answer. Question number 1. What is the primary function of the Linux shell? A. Manage hardware. B. Provide graphical interface. C. Interpret and execute commands. Or D. Store files. What is the primary function of the Linux shell? A. Manage hardware. B. Provide graphical interface. C. Interpret and execute commands. Or D. Store files. Give you 5 seconds to think about it. 5, 4, 3, 2, 1. The answer is C. The shell acts as the interpreter between the user and the operating system. It takes command, processes them, and executes system-level actions. Question 2. Which command provides real-time monitoring of system processes? A. PS. B. ls. C. top. D. cd. Which command provides real-time monitoring of system processes? A. PS. B. ls. C. top. Or D. cd. Give you 5 seconds to think about it. 5, 4, 3, 2, 1. The answer is C. Top. It continuously updates system activity, showing CPU and memory usage dynamically, unlike PS, which provides a static snapshot. Question number 3. What is the purpose of sudo in Linux? A. Delete files. B. Switch directories. C. Run with elevated privileges. Or D. Restart system. What is the purpose of sudo in Linux? SUDO in Linux. A. Delete files. B. Switch directories. C. Run commands with elevated privileges. Or D. Restart system. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And the answer is C. Sudo allows users to execute specific commands with administrative privileges without fully switching to the root user. Right? Should be done temporarily, right? Last question. Hopefully you are 3 for 3 so far. And let's do like Wendy's and go 4 for 4. That is so corny. Anyway, what is the primary role of Time Machine in macOS? A. Install apps. B. Monitor system performance. C. Backup or restore files. Or D. Manage permissions. What is the primary role of time management in macOS? A. Install apps. B. Monitor system performance. C. Backup and restore files. Or D. Manage permissions. Give you 5 seconds to think about it. 5, 4, 3, 2, 1. The correct answer is C. Time Machine. Time Machine does backup and restore files. C. Right, backup and restore files. Time Machine provides automated backups and allows users to recover files from previous states. So if you made it through the entire 2 episodes that I've done, you've already done something most people don't. You didn't just learn commands, you learned how systems are structured, how access is controlled, how behavior is monitored, and how different interfaces present the same reality. And that's the difference. Anybody can memorize ls, chmod, or top, but technicians understand why those commands exist. Because in the real world, you won't always know the system, but you will understand the principles. and you will always find the answers. All right, this has been Technology Tab. I'm Professor J. Rod. Stay sharp, stay curious, and as always, keep tapping into technology. This has been a presentation of Little Cha Cha Productions, art by Sarah, music by Joe Kim. We're now part of the Pod Match Network. You can follow me at TikTok at Professor J Rod, that's JROD, or you can email me at ProfessorJRod, JROD, @gmail.com.